Welcome to the fascinating world of ionic bonding, where atoms come together in a dance of electron exchange to create some of the most stable and essential compounds in nature. Imagine a scene where atoms are like characters in a story, each with their unique traits and desires, forming bonds to achieve balance and harmony. At the heart of ionic bonding is the quest for stability. Atoms are like puzzle pieces that strive to complete their outer electron shells, reaching a state of lower energy and maximum stability. This desire drives them to either give away or accept electrons, leading to the formation of ions and ultimately ionic bonds. Metals, the generous givers. Profile? Typically found on the left side of the periodic table, metals are elements like sodium, Na, and magnesium, Mg. These atoms have a few electrons in their outer shells and are eager to donate them to achieve a full stable shell. Action. When a metal atom loses one or more electrons, it becomes a positively charged ion or cation. For example, sodium loses one electron to become Na+, and magnesium loses two electrons to become Mg2+. Nonmetals, the greedy gainers. Profile. Located on the right side of the periodic table, nonmetals include elements like chlorine, Cl, and oxygen, O. These atoms are just a few electrons short of a full outer shell and are keen to grab the electrons they need. Action. When a non-metal atom gains one or more electrons, it becomes a negatively charged ion or anion. For instance, chlorine gains one electron to become ClO, and oxygen gains two electrons to become O2. When a metal and a non-metal encounter each other, a remarkable exchange takes place. The metal, with its extra electrons, generously offers them to the non-metal, which eagerly accepts them. This transfer of electrons transforms the atoms into ions. Sodium and chlorine. Sodium, Na, loses one electron to become Na+. Chlorine, Cl, gains that electron to become Cl. The result is the formation of sodium chloride, NaCl, or table salt. This electron exchange leads to the formation of oppositely charged ions, which are now attracted to each other like magnets due to electrostatic forces. This attraction is the ionic bond. Ionic bonds are incredibly strong because they are based on the powerful electrostatic attraction between positive and negative charges. This strength gives ionic compounds their distinctive properties: high melting and boiling points. Ionic compounds require a lot of energy to break the strong bonds between the ions, resulting in high melting and boiling points. This is why table salt remains solid at room temperature and melts at high temperatures. Electrical conductivity. In solid form, ionic compounds do not conduct electricity because the ions are fixed in place. However, when melted or dissolved in water, the ions become free to move, allowing the compound to conduct electricity. Crystal lattice structure. Ionic compounds form a regular, repeating pattern called a crystal lattice, where each positive ion is surrounded by negative ions and vice versa. This orderly arrangement contributes to the hardness and brittleness of ionic solids. Table salt, NaCl, sodium, Na, from your kitchen salt shaker, and chlorine, Cl, from the bleach in your laundry team, up to form NaCl, an essential compound for life. Magnesium oxide, MgO. Magnesium, Mg, often found in fireworks for brilliant white flames. And oxygen, O, from the air combined to form MgO, a compound used to line furnaces. Calcium carbonate, KCO3. Calcium, Ca from limestone and carbonate, CO3, come together to form KCO3, a substance found in chalk, marble, and the shells of marine organisms. Ionic bonding is a cornerstone of chemistry, illustrating how elements interact to achieve stability. This powerful type of bond not only helps form the substances that make up our everyday world, but also highlights the incredible balance and order inherent in nature. Through the dance of electron exchange, atoms achieve stability, transforming into ions and creating compounds with remarkable properties. Whether it's the salt that seasons our food, or the minerals that build our bones, ionic bonds are a testament to the intricate and fascinating world of chemistry. So, next time you sprinkle a pinch of salt on your meal, take a moment to appreciate the ionic bonds that make it all possible, a microscopic marvel playing out in the palm of your hand.